In this video, we're going to look at how the four properties of gases are related to one another. So we want to know how the four properties of gases are related to one another. We want to know how the pressure, the volume, the number of moles, and the temperature are related. Now what we're going to do is we're going to consider each one in pairs. If we try to compare too many things at once, then it's too complicated. We don't know what is influencing what. And so when we compare each pair, the other two properties need to be kept constant. All right, so first let's consider how gas pressure and volume are related. And this particular relationship is called Boyles Law, but I don't actually care if you know the names of these particular relationships. So if we consider a gas trapped inside a piston, if we decrease the volume by pushing down on that, that increases the pressure inside of the gas. Because now the gas molecules don't have to travel as far before they strike the walls of the container. And so a decrease in volume results in an increase in pressure. And so what we would say is that because when the volume increases, the pressure decreases, or as we're seeing here, when the volume decreases, the pressure increases, we would say that they are inversely proportional to one another. And so we might represent it with an equation like this. This symbol represents proportionality. So because they're inversely proportional, volume is proportional to the inverse of the pressure, or volume is proportional to 1 over the pressure. And so if I wanted to get a straight line, if I plotted 1 over P on the x-axis and volume on the y-axis, then that would give me a straight line, because now I'm plotting the inverse of pressure versus the volume. All right, so I don't want to go through all of these individually. What I'd like you to do instead is to make use of this animation, and the website is given here, and use this to explore all of these relationships. And so we want to be familiar with these 6 relationships. So we just talked about pressure and volume. We said those are inversely proportional. And so then there are 5 others that we want to explore. And I think a lot of these are, you can probably come up with these on your own if you think about them, but the simulation is kind of fun to play around with. All right, so let's take a look at the simulation together a little bit, and then you can explore it on your own. So when you type in the address I have on the previous page, you can see it on the top of the browser here. We want to click on Ideal. And so to get the simulation started, use the little pump with your mouse and inject some gas into our chamber. And so we want to investigate these variables in pairs. So first, let's take a look at the relationship between pressure and volume, which we've already talked about. But let's confirm that with this simulation. And so as long as we don't inject any more gas, the number of moles will stay the same. But if I want to compare pressure and volume, then I can adjust the other thing I'm keeping constant in the menu on the right there. So click on temperature to keep it constant. And then if I want to change the volume, I can click on the handle on the left there and drag it. Right, so my pressure was about 11.7 atmospheres. Now that I've decreased the volume, you can see the pressure increased. So a decrease in decrease in volume increased the pressure, right? Or if I drag it back out, I go from 23 atmospheres to 9.4. So we can confirm that pressure and volume are inversely proportional. So what about temperature and volume? So if I want to keep the pressure constant, right, if I'm comparing temperature and volume, I need to keep the pressure constant. So I clicked on the pressure, and then the up and down arrow with the V means that I'm going to keep the pressure constant, I'm going to allow the volume to change. And so then to change the temperature, that bucket on the bottom, if I want to increase the temperature, I'll drag that up. Right, so you can see the temperature went from about 300 to 384, and then the volume increased, right? So an increase in temperature increased the volume. If I decrease the temperature, right, my temperature went from 380 to 257, right? A decrease in temperature decreased the volume. So we would say that volume is directly proportional to temperature. Let me do one more, and then you can explore the others. Let's see how temperature and moles are related. So I'm going to keep the pressure constant by clicking on the pressure, and I'm going to allow the temperature to change. So the volume will also be fixed. Um, and so if I increase the number of moles now, let's see what happens to the temperature. So the temperature is 257. I increase the moles of gas, and you can see the temperature goes down, right? And maybe that makes sense, right? Because the more molecules I have, the higher the pressure is going to be. So as we'll talk about later on, the temperature is a measure of the average kinetic energy. So in order to keep the volume and the pressure the same, if I inject more gas molecules, the temperature has to go down. So then we would say that temperature is proportional to 1 over the moles. So temperature and moles are inversely proportional. So I want you then to explore the other relationships. Let's just do one more for fun. If I want to know how temperature and pressure are related, I'll keep the volume the same. As long as I don't inject any more gas, I can't change the number of moles. And so if I increase the temperature, you can see the pressure also increasing. So pressure and temperature are directly proportional. So I encourage you to play around with the simulation and confirm all of the possible relationships between the 4 properties of gases.